plus 3, I can deal with that like it was one term. It's multiplied by x plus 3. Okay? I wanted to solve step by step to make it easy for me, right? So first, I take this x plus 3 and deal with that like it was one variable. So I take it as x plus 3, and then I look at the power, it's power of 2. It means that it's multiplied by itself 2 times. Then, if I want to expand, do you know what is the easier way? To ignore this 3. Ignore it like it's not exist. And look at this x and multiply it by all the other sides or all the other terms of the next bracket. So it's going to be x times x, which is x squared. And x plus 3, which plus 3x. Do you know what I'm doing?
Yes.
Okay, then I will ignore the x and start to deal with what? To deal with this 3. To multiply it first by the x and second by the 3. So it's going to be plus 3x plus 9. You get it?
Yes.
And then we can simplify it. How can I simplify it?
Combining like terms.
Okay, like terms, very good. What is the like terms? It is a term that has the same variable and the same power, right?
Yeah.
Which is 3x and 3x. Don't be bored from me if I make it in details, because it's the first time to listen to you and I don't know how could it be with you. Okay, because of that I say it in details because I just don't want to ignore any information that you didn't know already. Okay,
Okay, no problem.
it's okay. So here x squared can't be simplified, so I put it here, and then I'll take this 3x with 3x. It's gonna be
6x.
yeah, and finally plus 9, and we finish this expanding form. Any problem?
No, not so.
Can I give you a question about expanding?
Yeah, no problem.
Okay, go ahead. You can control writing. If you can write. If you don't, you can tell me and I will write.
Yeah, no, I can't write, I don't think.
Okay, just tell me and I will write.
Okay, so we do 2x into x squared, so that's 2x cubed
Okay,
plus 6x.
6x what?
Squared.
Yeah, because I'm here. Just remind yourself all the time, okay? So I'm here. It's gonna be 6x squared, okay?
And then minus 2x.
Okay, minus 2x. And then?
And then we have minus 5x squared.
Yeah, super. 5x squared. Okay.
Minus 15x.
Very good.
Plus 5.
Okay, very good. Now, what about the like terms? Do we have any?
It's 2x cubed plus x squared.
Okay.
Minus 17x.
Okay.
Plus 5.
Okay, very good. Now we get a polynomial. Could you tell me here about this polynomial if you wanted to get the number of terms? And
4 terms.
4, okay. And the degree?
3.
Okay, very good. And finally, what? Do you remember the other one? Leading?
The leading coefficient.
Yeah, which is?
2.
2. Very good. This is the first part of our lesson, and I guess you are understanding it well. Sorry? Yes or not?
Yeah, I'm understanding as well.
Okay, very good. Then I just want you to take care of something. It's what? It's common mistakes. All the time I give my student golden rule and common mistakes. Okay?
Okay.
What about common mistakes that a lot of students fail out of it? First, they forget to multiply all terms. Because of that, all the time until now, for myself, I do this rows and finally I remove it. Okay? Second, not
Okay.
combining all terms or like terms, of course. And finally, not writing in standard form. In standard form. Okay? What is the standard form? Here, if I want to write 5, the last one which we solved together. If I write it with x squared plus 2x cubed minus 77x plus 5, it's not right because it's not the standard form. The standard form must begin with the highest power, right?
Correct.
So here, if you want to write it as a standard, you're gonna make 2x power of 3 plus x power of 2 minus 77x plus 5. Until now, any problem?
No, miss.
Okay, very good. So here we said that highest power equal degree and leading a coefficient, we said it. And finally, I need to ask you about thing. If you get your degree, okay, if you get your degree as the last question with 3, it means it's odd, okay? Because sometimes he asked you about is it odd or not? So it's odd. He will not say the degree is odd or even. He will say the polynomial is odd or not. So here you are going to get the degree. It's 3. It's odd. So it means that polynomial is what? Is odd. Do you know
Oh,
what I mean?
yeah, I understand.
Okay, very good. And then I just wanted to remind you about it. Do you remember that if we have something or name is like a domain and another name which like a range? Do you ever listen these words?
Yeah,
Okay, what is a domain? All the time, my domain equal what? If I have a grid here and I want to represent anything, what is a domain that I have to know? It is a
yeah.
value
Domain
x or y?
is the Y.
No. All the time, domain is x and the range is y.
Oh, okay.
Okay?
Okay.
If you have any value,
Okay.
if you have a straight line like that, and I take some points and I want you to get for me the domain and the range for this function. Of course, it's called a function. Do you know why it's called a function? Because there is in this kind of questions, we have some kind of function and some kind of relation. Maybe the
Mm,
question comes like a relation and sometimes it's a function. What does it mean or what does it make difference? If you want to make it by your eyes, only with your eyes, and you have some kind of graph like that, look, what does it mean? This is a relation or a function. How can I know in my eyes, with my eyes only? First, you need to look at each point here and make a vertical line. While you are making a vertical line like that, you will ask yourself, you have one value on x or two values? About here, it's one value, right?
right.
So if it was one value, it's a relation and function. But if you have some kind of that, look, and you get your graph like that, oops, if you are going to get your vertically lines, you will say that there is some values has two values of x, right?
Right.
Which means that's not a function, and this is a
Mm,
relation. Only a relation between some kind of coordinates, but it has no function. Okay? So I can't put an equation and say you can follow this equation to answer your questions. So here, about the domain and the range. Sometimes you see, here, just give me a minute, you see some graph like this. And sometimes you can see your graph like this. And sometimes you can see your graph like this. right?
Right.
What is the difference here? Could you tell me what's the difference that you know? And then I can continue.
Not really sure.
Okay, very good. Let's start together. If I have coefficient which has a degree of 3, which means that my function is going to be like that, y equal to x power of 3 minus x, okay? Which means that my degree is what? Is 3. So it's odd,
Yeah.
okay?
Okay.
Okay, and what else I can see? I can take from this line or from this graph.
Uh, you mean like the leading coefficient
Yeah, very
and
good.
the number of polynomials or number of terms, sorry.
Leading a coefficient. Leading coefficient is 2, which is positive, right?
Yeah.
Okay, very good. So here my results must be left, down, left, down, right, up. What does it mean? If I have some kind of the graph which has on the left of the y-axis, I'm going down. On the right of the y-axis, I'm going up. It means that my degree must be odd. Did you understand what I mean?
Okay. Yeah, I understand.
Okay, easy or difficult?
Easy.
It's okay. Now I can see some kind of that. Look at this graph. This graph is look like what? Maybe y equals x squared plus 4. Okay? Your x
Okay.
squared plus 4, it means that your degree is 2, which is even. If I'm even, it means that what? It means that I'm going up. Left and right, I'm going up.
Okay.
Okay? Very good. So the degree is 2, so it's even. So I'm going up. Okay? But with one condition, that my leading must be positive. Because my leading here is plus 1 or positive 1. So it's positive. So you are going up. Did you know what I mean? When I can see
I know
the
what you mean.
graph, of course, sometimes you see some kind of graph like that. Okay? I just wanted to know
Okay.
it's like that. So here, plus 2. Do you know why I write here plus 2? Because if it was only 1, the graph must be like that, must be on the origin here. Look.
Mm.
But here it has two coefficients, so maybe it's some kind of that. Okay? Like this. Look at this.
Okay.
Look at this graph. It's locking down. What does it mean in locking down? It means that leading, if it was locking down, so you must see the coefficient or the leading coefficient is what?
Negative.
Negative. Must be negative. Okay? And if it was going here on the right and on the right, yeah, and on the left of y-axis, they are going on the same sequence, it means that your degree must be even.
Okay.
Concentrate with me because fine, at the end we will open your sheet and take all of this information about your sheet. Okay?
Okay.
Okay. So I just explaining the sheet simply and step by step, and finally we will open your sheet. So here, if we are going to make this, we will see that leading coefficient is negative. Look, maybe it's like that. Y equal negative 2x power of 4 plus 2x power of 2. You will say, oops, we have x power of 2 here and the coefficient is positive. I will say, never mind, don't look at this. Just look at what's the highest one, the highest degree, and the leading coefficient, which is negative here. Right? Until now, any problem?
No.
So left, when you are left, you are going down. When you are right, you're going down. This is the result of the degree is even and the leading coefficient is negative. let's make a shortcut to make it easy. If I have wood, it means they are opposite. What's the meaning of opposite? Like that.
Mm.
Right? I just wanted to make it clear like
Okay.
that. Okay? So it's wood, which means they are opposite on the right and the left of y-axis. It is here. I can say that this is a command here. Okay? The other
Okay.
shortcut coming from what? Coming from if they are even, of course, time means a degree. If they are even, so they are the same on the right and the left of the y-axis. Right?
Right.
If it was positive, if I'm looking for the positive and negative, so I'm talking about the leading coefficients, right? So
Yeah.
positive or negative, it will give me a very important question or a very important data. What is it? If it was positive, it means it's right goes up. Right goes up. Like what? Like that. Okay?
Okay.
And if it was negative, it means what? That right goes down. Now it's okay?
Yes, it's okay.
So finally, if I give you a graph and I ask you about all just with your eyes to give me some information here, and I ask you, do you think that the degree here is odd or even?
Odd.
Odd, very good. And what do you think about the leading coefficient?
I say if it's odd or even.
Sorry?
I say if it's odd or even.
No, it's positive or negative. Positive and
Oh,
negative, it's coming for the leading coefficient. So here it's gonna could be positive. Okay?
okay.
Okay. And if you see some kind of this graph, look, give me about the degree, a data about the degree and leading coefficient.
The degree is even and the leading coefficient is positive.
Positive, very good. And finally, if you have some graph like that, so the degree,
The degree's leading coefficient is negative.
the degree is, sorry?
Even.
Yeah, very good. A lot of students get confused here because he thinks that all the time if it was the leading is positive, it means the degree is odd, okay? But you are getting it great. So the leading is negative. Until now, any problem?
No problem.
Okay, very good. I guess we finished that topic too. About the topic 3, we started to talk about the domain and the range, right?
Correct.
Look at this and give me the domain. First, the domain must be, let's look at this grid. Let's make it very clear. Okay, okay. And we will start together. If I want you to get for me the domain, so gonna be where? Could you point to me? Where is my domain?
Domain,
It's related to
yeah,
what?
the x-axis.
Okay, very good. So it can be here. Do you know
Yeah,
this row means what?
the x-axis.
No, this row direction means what? Means
It's
positive.
like infinite.
Yeah, infinite positive. And this row direction means what?
Negative infinite.
Yeah, very good. So let's look at here. And of course, it's the same here, up and down. But it doesn't make matter here. Just stay with me about that. Here, about the domain. For all the polynomial, okay, it's gonna be negative and positive. Why? Because it's very, very opened. Why? If we want to draw some kind of polynomial like that, polynomial graph like that, it means that while I'm going to put a x or the domain value, it will give me another range value. So I can extend it like that and I can extend it like that. It will never end, right? Do you know what I mean?
Yeah.
Do you know what I mean? So here, if we want to get the domain here, I have to know that the domain is opened on the right and opened on the left. Opened on the right, it means what? It means positive infinite. And opened from the left, it means what? It means negative infinite. And of course, I write the small value first. Okay? Now it's okay? Any problem in that?
Nothing.
Okay, very good. What about the range? The range make a little different. Okay? Let's do it together. If I want to get the range,
Ranges
sorry,
ranges up and down, right?
range is up and down. Why it's up and down? Maybe sometimes it's up and down, maybe sometimes it's up and up, right?
Yeah.
So let's look at this and start to ask ourselves more times here. While I'm extending this up, look, and while I'm extending this down, here, the range must be what? Let's look at y. Of course, range is related to y-axis, right? Let's get y-axis,
Correct.
y-axis value, y-axis value, y-axis value, y-axis. Oops, they're extending, right? They will never end. So it seems like y equal x cube. So my range here must be negative infinite and positive infinite, right? Because it will never end.
Right.
Okay, very good. There is another graph like that. Let's look at it here, if I see it. And I see that we have a graph like that. Look. Can you say that this range is gonna be negative infinite and positive infinite?
No,
Why? Why it's not right?
because it stops at the minimum point is at 0.
Very good. So there is no negative here. So I have to say what?
Yeah.
I can exchange this negative with what? With 0,
With 0.
because this is the minimum value. So 0 and positive infinite. Until now, any problem?
No, no problem.
And what if it was the inverse? Look, some kind of that. Here, what's my range?
Your range is uh 0 to negative infinity.
But we can't say write 0 at first because 0 here is a maximum value, right?
Correct.
So I have to write what first?
Negative infinity
Yeah, and then 0.
to 0.
All the time you have to write the small value at the left, okay?
Okay.
So any problem until now?
Mm, no, not at all.
Now, from the beginning or from the first second that you can see any graph like that, you can take a lot of informations, right? About the domain, about the range, about the degree, about the leading coefficient, about what else, about the number of terms. All of that you can take it, right?
Yeah.
Okay, so let's make an example. Let's try. Hmm?
Okay.
Okay, if I say that we have
Okay.
a
No.
polynomial like what? Like 5x squared plus 2x minus 7. And I ask you some questions. Or we can ignore this plus 2x. Let's make it minus 7 only. Or plus 7 only. It's okay to make it easy. So here, it's a polynomial, right?
All right.
Okay, what else you can tell me? Here, I want a lot of information.
Okay, for the graph that's no, okay. So the leading coefficient is
Yeah.
5.
Okay.
The degree is 2.
Okay. What else? Number of terms.
Number of terms is also 2.
Okay. If you want to talk about the domain and the range.
I'm not sure, but I know that since it's even
About the
power
domain,
and
I just don't want to be confused about the domain. There is no difference for all the polynomial, and to make it easy. For all the polynomials, the domain is very, very, very opened. Why? Because all the time the domain I suggested, right? If I give you this, if I give you this polynomial and I tell you draw it for me, how could you do it? You will start to assume numbers of value. Maybe you start with negative 1000. Anybody can tell you anything? No, you can do it. So your function must be what? Must be 5 and multiplied by negative 1000 power of 2 plus 7. And you finish your question, right? So you can open it.
right,
It's opened. You can do anything in assuming values, right? So your domain here on all the time must be negative, infinite, and positive infinite. It's for all that polynomial, right? Remembered?
right.
Okay, the next one, you have here some kind of range. But before we say the range, we need to get what? If the degree was 2, it means that, do you remember? The odd and even and opposite and
It's
negative.
even. Yeah, it's even. So
Okay. So it means that you remember the shortcut. I will send you for you this PDF and I want you to revise it. If it was even, it means that you can see the same drawing on the right and on the left of the y-axis, right?
right,
Okay, what about the leading coefficient? It's positive, right?
correct,
If you get back to our shortcut, you will say that if it was positive, it's gonna be right goes up. So it means if I want you to start to imagine the shape of the graph, could you do it? But before that, could you tell me the range? Or if you want to draw it first, it's okay. Or tell me which shape of that, 1 or 2 or 3, if you can't control writing.
okay. So the shape, since it's positive and even, is a parabola that goes up
Yeah,
2.
2, very good. So if I wanted to draw some kind of that, maybe like that. To just make it like that, I just wanted to make a very, very, very small edit to make it here. Okay, there gonna be. Okay, it's okay. Let's make it here. Don't worry. So here, 5x squared plus 7, and I put this drawing. What about the range? Where is my range here?
The range is from 0 to infinity,
Yeah,
to
super,
positive
very
infinity.
good, very good. Until now, any problem?